If you've taken the steps to learn CAD, then it can be a really rewarding experience to design and make your own sheet metal parts for your vehicle. Unfortunately for some of us, we don't have local laser cutters, but now there are options in the form of SendCutSend, for example. We're here with Jim to talk about his service. So Jim, we're here at SendCutSend. The name is somewhat self-explanatory, but could you explain what service you provide and I guess like how that filters into the automotive aftermarket?
Yeah, we are a rapid manufacturer, so on-demand manufacturing. What that means is send us your design, we'll produce it for you and deliver it right to your door.
Right, so in terms of sending you the design, CAD files, lots of different file formats, 3-letter acronyms and things, can you explain what format people would send something to you?
Yeah, our preference is DXF format because it's very universal. If you're using any kind of CAD software, usually it can output as a DXF. If you're doing something that's more artsy or creative, a lot of people prefer Adobe Illustrator or some sort of illustration program. So we do accept Adobe Illustrator files natively as well as EPS files.
Right, so those are all based around, I guess, like 2D outlines of profiles for parts to go along with the 2D cutting processes you're using. Step files, is there room for something like that in the future with
Yes.
3D models?
Yes, step files are something that we're going to be offering, especially for sheet metal bending. So three-dimensional bending is often done in SolidWorks or Fusion 360, where you're calculating all the radiuses and how everything goes together. Today, we request that you flatten that pattern out so then we can manufacture it and then bend it. But in the future, we're hoping that you can just give us the step file and we'll flatten it out and figure everything out for you. Right now, that'll probably be coming towards the end of the year, so next month or so.
Yeah, cool. Yeah, I guess with the step file, with that 3D thing, it captures the design intent a little bit more and you're able to see what the person is expecting as the final product.
It is. Yeah, the reason that we didn't launch with step is because there's some things that you can design that aren't manufacturable. So in the step file, if you design it with a thickness that we don't offer, or perhaps like a bend radius that we don't offer, we would have to reject the file. So with this new release, we're actually making recommendations and suggestions in real time to help you design to something that we can make instead of just something that no one can make.
Of course. So that kind of brings us on to the next topic. Nowadays, it's getting so easy, accessible to get into CAD software, especially with Fusion 360 being essentially free for personal use. But with modern computers and everything, it's a lot more usable for people. And to get the basics under control, it's a lot easier than maybe some people think as well. But obviously, once you've learnt to model, you can basically model whatever you can think up. And maybe that comes with some issues for people who aren't so familiar with the manufacturing process. So design for manufacturing, or DFM, is a pretty common thing that we hear. Can you just explain a little bit what that is and how you deal with those issues?
Yeah, DFM is a huge challenge because our customers are very creative. So every time we think that we can predict a DFM issue, someone will come up with a way around it. DFM is something that we have a team dedicated to every single day since we've started. So today we look for overall part size to make sure that it's within, the raw goods. It has to be certain dimensions. It has to have certain geometry. So small geometry in really thick material is challenging. So small holes in 1/2-inch thick aluminum are really challenging to produce. We also look at bending and bend collisions. That's a huge problem because maybe you can make it work in sheet metal on the screen, but making it work in sheet metal when it's like a folded box with 15 different bends, it may not be possible with the tooling available. So for us to educate in real time as you're ordering is huge. And I want to be able to say, hey, you forgot a bend relief right here. Would you like us to add one? Hey, this is going to collide. If we change this angle a little bit, it'll make your project successful. So it's a back and forth of us teaching them and them challenging us.
Yeah, right, that makes sense. Bend reliefs, especially one that maybe some people don't know about. I know there's some tools in Fusion 360 with their sheet metal rules that allow you to apply those automatically. But yeah, it's definitely something that comes with more experience with the manufacturing process and design and learning from the failures and stuff, but it's good to be able to highlight that to people beforehand. On the topic of DFM, I talked to you a bit earlier about potential plugins for software.
Yes, we have a plugin for SolidWorks right now, which is in its beta phase, but we're able to leverage that architecture and go directly to our Fusion 360 plugin. So what that plugin allows you to do is, while you're in the Fusion 360 platform, if you have a design, our plugin will tell you right then, like, yes, this is manufacturable. Why don't you tell us what material it's in, or we detect the material from Fusion 360. We can give you pricing in real time. And then our end goal is ordering directly from Fusion 360 or SolidWorks without ever needing to come to our platform. So the SolidWorks is in testing right now, and I'm hoping Fusion 360 comes right after that.
Yeah, no, that'd be really cool, given Fusion 360 being so accessible to enthusiast levels. In terms of the DFM, the issues that you see, could you give us maybe the top few issues that you see commonly with people oversights with their designs?
Yes, small geometry, like I said, so tiny features in thick materials. The thicker the material, the larger the geometry needs to be. Because remember, we're pouring a lot of heat into that area, very briefly, but we run into melting issues if you're trying to put a hole that's 30 thousandths in diameter all the way through a piece of half-inch aluminum. So our accuracy starts to decline. Doing a half-inch hole in a half-inch aluminum is zero problem. So understanding the limitations of the material as well as the cutting process is important for us. The other DFM issue that we run into is geometry that's near the edge of an object. So if you want to put a slot or something that's a millimeter away from the edge on a piece of material, we can probably do it, but it most likely will fail while you're holding it. The metal is very strong, but when you cut it really thin, it behaves like spaghetti noodles. So sometimes people just imagine that, oh, this titanium is crazy strong, but if you cut enough holes in it, it'll be as bendable as like a piece of Kleenex.
Yeah, so on the topic of material, it can be somewhat overwhelming to people when they're first getting into designing parts and getting them made, fabricating themselves, or using a service like your own. There's a long list of different materials to choose from: stainless, titanium, aluminium, and then within that there's also all the different grades, and sometimes it can be difficult to know what you really want or what would be best for your application. So can you guide people around making that decision?
Yes, very much. On our materials pages, we give a description of every material as well as common uses. So for example, in aluminum, we offer 3 different grades. We have 50-52, 60-61, and 70-75. And those are just random numbers. I mean, they represent the alloy, but as someone who's trying to make a part for their custom build, how do you decide, what's going on? When you go to our website, you can click on any material and we'll say, hey, this is actually the best compromise of value versus strength, or if you need strength at all costs, then we recommend this. We're building a tool that'll help you choose, and that'll be rolling out here pretty quick. The answer is usually aluminum. That's the joke inside. Usually if you need an exotic alloy, you already know that intent. If you need titanium for a heat shield or something, then you can come choose one of our grades. But again, coming back to DFM, that's when we like to look at the part and say, will this material be good for the application? So it's hard to do that only using software, and that's why we have a huge DFM team. We have a team of application engineers that are available 24/7, and they will review your file and say, hey, this is way overkill, or this is not going to work. We don't give engineering recommendations, but if you need a box that's formed with 5 or 6 different bends and you choose titanium, we'll probably give you a different recommendation.
Yeah, right. No, it makes sense. And especially with the aluminium, it's very useful in automotive applications, being so light, which is super important to us, obviously. But sheet metal in general, being able to use a relatively thin material that's lightweight and then strengthen it, stiffen it with bends, it's a massive advantage to us. So Just back on the topic of DFM, or similarly DFA, or design for assembly, people, especially of sheet metal parts, potentially wanting to get a few parts cut and then weld them together. The tab and slot method is becoming more popular, or it's been around for a while, but it's very useful. Can you just talk on that a little bit? What's its use, and do you see it used often?
Yes, so tab and slot, or self-fixturing, is one of our favorite design methods, and you can see a bunch of examples in this booth. Especially for welding, if you've ever tried to weld just a couple squares together, they're moving around. You need a bunch of magnets and clamps. In order to eliminate that, if you're smart in the design process, it'll save you hours during the manufacturing process. That's one of the things that we set out to do with this car. Is we put 190 hours into design, but the assembly only took 22 hours. So with tab and slot, if you're willing to put in the effort, it'll pay off when you actually flip your hood down. We offer recommendations for tab and slot clearances for every material. So it varies with material thickness, how much clearance you want to give. The thicker the material, the more clearance. A good rule of thumb is about 5/1000ths of an inch all the way around. As you get thicker, that'll go up to 10 or 15 thousandths. We want to make sure that it's not necessarily press fit, because our tolerance is still about 2 or 3 thousandths of an inch. But if you leave yourself enough wiggle room, everything will come together, and during assembly, especially if it's 3 or more pieces, it'll set you up for success much more than not having tab and slot.
Yeah, of course. On that topic of tolerances, I mean, that's the main point of the tab and slot method, is to take away the errors with jigging or fixing the part together. That's also something that people need to consider when talking about bend lines and things like that. Any manual process definitely adds a chance for more discrepancy between their original intentions. Is there any other methods you can think of that would help with getting around those tolerance issues?
Yeah, tolerance issues are challenging because you can have an accumulation of tolerance, especially as the part starts to get larger and larger. Our manufacturing will hold tolerance regardless of size, but humans can't. So as you start to add more and more pieces, that tolerance will float away. One thing that we see customers do is actually make a sacrificial jig out of a low-cost material like MDF or chipboard or hardboard, and they will use that as a secondary alignment feature and place it on there, and maybe they cut it out at the end after welding, or they let it burn up. So those sacrificial jigs are really cool on complex pieces.
Yeah, no, that's awesome to hear. Well, thanks for your time, and if anyone wants to find out any more about your service and potentially order some parts, how can they do that?
SendCutSend.com.
Thank you very much. Cheers.
Thank you.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.